And now in this lecture we'll answer two questions. In the first question we find out the perimeter of this quadrilateral ABCD. And in the second question we find out the area of this green shape. So we start with the first question. In the drawing we have quadrilateral ABCD. We know that line 7PQ equals to 10 units in its length, line 7PQ equals to 20 units in its length, line 7QC equals to 40 units in its length. This is a right angle, this is also a right angle, and this is angle PQC, that is also a right angle. Again, our task is to find out the perimeter of this quadrilateral ABCD. So, what is a perimeter? A perimeter is the sum of its four side lengths of this quadrilateral ABCD. That is to say, it is equals to AB plus AD plus DC plus CB. So the sum of the four side lengths of any quadrilateral is equals to the perimeter of the quadrilateral. So in the first step, we will do a construction. That is to say, we will draw a perpendicular on AD at point P. Again, we draw perpendicular on AD at point P. Especially this angle equals to 90 degrees in its side, and this angle also equals to 90 degrees in its side according to our construction. We'll extend the perpendicular from point P until it touches side BC. And when we find the touching point of the extended perpendicular from point P and BC, this point is point M. By doing this construction, we find that here those two angles are defined as one-sided interangles, and the sum of those two one-sided interangles is 90 degrees plus 90 degrees is 180 degrees. And because of the fact that the sum of those two one-sided interangles is equal to 180 degrees, they must be located between parallel lines. That is to say, AB is parallel to PM. According to Rule 18. So repeat quickly on Rule 18. According to Rule 18, if the sum of two one-sided interangles is equal to 180 degrees, then they lie between parallel lines. So in the drawing, we have those two one-sided interangles. If the sum of those two one-sided interangles is equal to 180 degrees, that is to say, if alpha plus beta equals to 180 degrees, then they are located between parallel lines. That is to say, then line A is parallel to line B. We only implemented Rule 18 in our drawing, because in our drawing we have those two angles are defined as one-sided interangles, and the sum of those two one-sided interangles is equal to 180 degrees, and therefore those two one-sided interangles must be located between parallel lines. That is to say, AB is parallel to PM. So, write it down. According to Rule 18, AB is parallel to PM. Likewise, the sum of those two one-sided interangles is also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DC. So we can write here that PM is parallel to DC. PM is parallel to DC according to Rule 18. Likewise, the sum of those two one-sided interangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to DC. AB is parallel to DC. So in total, if you found out that all the three line segments AB, PM and DC, they are parallel to each other, according to Rule 18. So in the drawing, we have three parallel lines. That is to say, AB is parallel to PM and it's parallel to DC. And we have also, this is line segment AD that connects the three parallels together by straight line. Again, AD connects the three parallel lines. Likewise, BC also connects the three parallel lines together by this straight line. And according to the basic proportionality theorem, whenever you have three or more parallel lines that are connected together by two other line segments, then the following relationship exists between the two line segments that connects the three parallel lines together. That is to say, a special relationship exists between AD and BC that connects the three parallel lines together. The relationship is as follows. AP over PD equals to BM over MC. Again, AP over PD equals to BM over MC. So, write it down. So, if you found out that according to the basic proportionality theorem, the following relationship exists between AD and BC that connects the three parallel lines together. AP over PD is equal to BM over MC. And again, according to the basic proportionality theorem, the following relationship exists between AD and BC that connects the three parallel lines together by a straight line. The relationship is as follows. AP over PD equals to BM over MC. It is given us the question that AP equals to PD. AP equals to PD according to what is given us the question. So if we define the length of line segment AP as X, then the length of line segment PD must be also equal to X because they are equal to each other according to what is given us the question. So here we will substitute AP by X, PD is also equal to X because they are equal to each other. So in this side of the equation we have X over X equals to BM over MC. X over X is of course 1. So 1 equals to BM over MC. Here we will multiply the equation by MC and get that MC equals to BM. MC equals to BM. If you found out that PM equals to MC, that is to say, at point M, BC has been bisected into two halves. Okay, at point M, side BC has been bisected into two halves. The first half is BM, and this equals to the second half MC. And again, the first half of BC is BM, and it is equal to the second half of BC, that is MC, and each half must be equal to BC over 2, because BC has been bisected into two halves. Again, the first half of BC is BM, and it is of course equals to the second half of BC, that is MC, and each half equals to BC over 2 because BC has been bisected into two halves. So in total we found out that BM equals to MC equals to BC over 2. But BC in total, BC side BC in total equals to BQ, that is 10, plus QC, that is 40. So in total BC equals to 10 plus 40, that is 50, and 50 over 2 is 25. And from this long equation, we will derive that BC equals to MC equals to BM equals to MC equals to 25. That is to say, BM equals to 25 units in its length, and MC also equals to 25 units in its length. So I write it down. This is side BM is equals to 25 units in its length, and this is side MC, that is also equals to 25 units in its length. What is the length of this missile line segment? What is the length of this missile line segment? QM. From the drawing, it is very easy to see that QM in total equals to BM minus BQ. So write it down. The missing side QM equals to BM minus BQ. So in total QM equals to BM. BM is 25 minus BQ. BQ is 10 according to what is given in the question. So in total QM equals to 25 minus 10, that is 15. So QM equals to 15 units in its length. This is the missing side QM that equals to 15 units in its length. In the next step, we will implement the Pythagoras theorem on this right triangle PQM. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle PQM, here by PT the formation for Pythagoras theorem. So in this right triangle PQM, PM squared, that is the square of the hypotenuse, is equal to QM squared plus PQ squared. And again, according to the Pythagoras theorem, in this right triangle PQM, PM squared, that is the square of the hypotenuse, equals to QM squared plus PQ squared. PM is the missing side, so we leave this as it is. So it is, we leave it as it is. So PM squared equals to QM squared. QM is 15, therefore QM squared is 15 squared, that is 225. Plus PQ squared. PQ is 20, therefore PQ squared is 20 squared, that is 400. So in total we should find out that PM squared equals to 225 plus 400, that is 625. So actually PM squared equals to 625. Here we take a root out of this equation and finally get that the missing hypotenuse PM is equal to the square root of 625, that is 25. So the length of the hypotenuse PM is equal to 25 units. This is the hypotenuse PM is equal to 25 units in its length. In the next step, we will do another construction. That is to say, from this point M, we will do perpendicular on DC again. From this point M, we will do perpendicular on DC. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We'll define the touching point of the perpendicular from point N and DC. This point is point N. Actually, by doing this construction, we can do the quadrilateral PM and C. Inside this quadrilateral PM and D, so this quadrilateral PM and D, we have 1, 2, 3 rectangles. the sum of 390 degrees is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So in quadrilateral PM and D we have right angles, and therefore quadrilateral PM and D is a rectangle. So I have to know, which if I know that the small quadrilateral PM and D is a rectangle. In the next step, we define angle QPM, this angle is alpha. So in the green triangle, the green right triangle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. BC is one side of quadrilateral ABCD, and therefore it is absolutely a straight line. So if we focus on the left side of the straight line BC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have the left side of the straight line BC at point M? We have this angle is equals to 90 degrees minus alpha, plus this is a right angle plus 90 degrees, plus this third missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. So 180 degrees plus the size of this third missing angle in total must be equal to 180 degrees, and therefore this third missing angle must be equal to alpha. Why? Because 180 degrees minus alpha plus alpha is 180 degrees. That is the sum of the angles on the left side of the straight line BC at point M according to rule 3. Therefore this third missing angle must be equal to alpha. So in this lower right triangle M and C, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha, according to the sub-rule that says that the sum of the angles in any triangle is equal to 180 degrees. So in the next step, we prove that those two right triangles can go into each other according to angle side angle rule. That is to say, this is the green triangle PQM, the green right triangle PQM. This can go into this right lower triangle, triangle MNC. So why those two right triangles can go into each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two sides, they are both equal to 25 units. That is to say, the hypotenuses of those two triangles are both equal to 25 units in their lengths, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So actually prove that those two angles and the side that is included between those two angles, that is side PM, in this green right triangle PQM, are corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, in this right triangle MNC. And therefore, those two right triangles can go into each other according to angle side angle rule. So I write it down. So if we found out that this is the green right triangle PQM. It congruent. This is the side of congruent. So this right lower triangle MNC, according to angle side angle rule. it again, we should find out that the green right triangle the green right triangle PQM can point to the right lower triangle MNC according to angle side angle rule. And for the fact that those two right triangles can point to each other, we derive that those two sides are also equal to each other, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can point to each other, therefore those two corresponding sides must be also equal to each other in their lengths. But PQ is 20, therefore MN must be also equal to 20 units in its length, according to the rule that I mentioned. Why those two sides are corresponding sides? Because here we have side PQ is in front, this angle that is 90 degrees along alpha. Likewise, side MN is also in front of this angle 90 degrees along alpha. So those two sides are the corresponding sides. Likewise, those two sides are both located in front angle alpha. This is side QM that is located in front of angle alpha. This is side NC that is also located in front of angle alpha. So those two sides are also the corresponding. They are also corresponding sides, and these two right triangles. And according to the rule dimension, the corresponding sides and congruent triangles are equal to each other. We derive that QM equals to NC, but QM is 15, therefore NC must be also equal to 15 units in its length. We already found out that PMND is a rectangle, but we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PMND, side PM is equal to the opposite side DN. But PM is 25, and therefore the opposite side DN must be also equal to 25 units in its length. Likewise, according to the sum rule, in the same rectangle PD and M, side MN must be equal to the opposite side PD. But MN is 20, therefore the opposite side PD must be also equal to 20 units in its length. That is to say, X equals to 20 units. And again, those two sides are equal to each other. That is to say, AP equals to PD. So PD is 20, therefore AP must be also equal to 20 units in its length. So if you found out that side BC in total is 20 plus 4, that is 50. This is side DC, that is 25 plus 15, that is 40. And this is side AD, that equals to 20 plus 20, that is 40. AB is the only missing side that is left to find. AB plus the 300 sides is equal to the perimeter of this quadrilateral ABCD. Okay, so actually we already found out that AB is parallel to DC. Again, according to rule 18, AB is parallel to DC. And because of the fact that AB is parallel to DC, quadrilateral ABCD is a trapezoid. What is the definition of this answer PM? Actually, this is the mid segment of trapezoid ABCD. Why it is a mid segment? Because MP divides AD into two halves, because the first half is AP, and it is equal to the second half PD. Each half equals to X. That is 20. Likewise, PM bisect BC. Why PM bisect BC? Because M is the midpoint of BC. That is to say, at point M, BC is being bisected into two halves. The first half BC is 25, and it is also, of course, equal to the second half MC, that is 25. So in conclusion, you can say that line segment PM bisect AD and also bisect BC, and therefore line segment PM is the midpoint of AD and BC. But what is the length of PM? Actually, the answer to the question is, you can know what is the length of PM according to the trapezoid mid-segment theorem. This is trapezoid ABCD, and this is the mid-segment EF. The mid-segment EF bisect AC and BD. AC and BD are defined as the legs of trapezoid ABCD, and the two parallel sides, AB that is parallel to CD, are defined as the bases of the trapezoid ABCD. And the mid-segment EF bisects the two legs. That is to say, it divides leg AC into two halves, A equals to EC, and likewise, EF divides the leg BD into two halves. That is to say, BF equals to FD. And according to the mid-segment theorem, the trapezoid mid-segment theorem, the length of EF in total equals to the sum of its two parallel bases, that is to say AB plus DC over 2. And again, EF equals to AB plus CD over 2. AB plus CD is the sum of its two bases over 2. So in total, we should find out that EF equals to AB plus DC over 2. You can implement the trapezoid mid-segment theorem in our drawing. Why? Because in our drawing, we only found out that PM bisect AD and bisect BC. AD and BC are the legs of trapezoid ABCD. AB and DC, the two parallel sides, are the bases of trapezoid ABCD. And PM is the mid-segment of trapezoid ABCD. Why? Because it bisects the two legs, AD and BC. So all the requirements of trapezoid mid-segment theorem are satisfied, and therefore we can implement here trapezoid mid-segment theorem. According to the trapezoid mid-segment theorem, the length of the mid-segment PM is equal to, according to trapezoid mid-segment theorem, the length of mid-segment PM of trapezoid ABCD, it will be equal to the sum of its two parallel bases over 2. The two parallel bases are AB plus DC over 2. So according to the trapezoid mid-segment theorem, we get that the length of the mid-segment PM of trapezoid ABCD, the length of mid-segment PM of trapezoid ABCD equals to the sum of its two parallel bases, that is to say AB plus DC over 2. But we already found out that PM equals to 25, so we can substitute PM by 25. Substitute PM by 25, and it is equals to AB. AB is the missing side, so leave it as it is. So it is AB plus DC. DC in total equals to 25 plus 15, that is 40 over 2. So in total we should find out that 25 equals to AB plus 40 over 2. Here we multiply this equation by 2, and finally we get that 25 times 2 is 50, so 50 equals to AB plus 40. Here we'll subtract 40 from this equation, and we get that the missing side AB is equal to 40, 50 over 40 is 10, so AB equals to 10 units in its length. This is the missing side AB, is equals to 10 units in its length. Repeat again, the perimeter of this quadrilateral ABCD is actually trapezoid ABCD, is equal to the sum of its four side lengths. So AB is 10, plus AD is 40, 10 plus 40 is 50, plus DC is also 40, so 50 plus 40 is 90, plus CB. CB is 50. 90 plus 50 is 140. So if you find out the perimeter of this quadrilateral ABCD, is equal to 140 units in its length. In the next step, and this is the answer to the question. In the next step, I present to you another way to find out that AB equals to 10. I prove in a different method that AB must be equal to 10 units in its length. Side AB of quadrilateral ABCD must be equal to 10 units in its length. So we will do a construction from point B. I will draw perpendicular on PM. So actually, this angle equals to 90 degrees in its sides, and this angle also equals to 90 degrees in its sides according to our construction. We define the touching point of the perpendicular from point B and PM. This point is point S. So by doing this construction, we get the right triangle BSM. This is the right triangle BSM. In the right triangle BSM, this angle equals to 90 degrees. This angle equals to 90 degrees minus alpha, and therefore this perpendicular angle must be equal to alpha. Only to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. We already found out that the hypotenuse BM of the right triangle BSM equals to 25 units in its length. It is very easy to see that those two right triangles can go into each other according to angle side angle rule. And again, those two right triangles can go into each other according to angle side angle rule. That is to say, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two hypotenuses, they are both equal to 25 units in their length, and therefore they are equal to each other. We already found out that BM equals to MC equals to 25. And finally, those two angles are both equal to 90 degrees alpha, and therefore they are equal to each other. So if you recall that those two angles and the side that is included between those two angles, that is side VM, on this right triangle BSM corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, this right triangle MNC. And therefore those two right triangles can go into each other according to angle side angle rule. So if you found out that the upper right triangle BSM congruent, this is the sign of congruent, to the lower right triangle MNC, and they can go into each other according to angle side angle rule. And again, I should found out that the upper right triangle BSM can go into the lower right triangle MNC according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that SM is equal to NC, or NC equals to SN. Again, NC equals to SM. According to the rule that I mentioned a couple of times, that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, and therefore those two corresponding sides must be also equal to each other in their lengths. Why those two sides are the corresponding sides? Because both of them are located in front of angle alpha. This is side NC, this is located in front of angle alpha. This is side SM, that is also located in front of angle alpha. And therefore those two sides are defined as corresponding sides, and therefore they are equal to each other, according to the rule that I mentioned. But NC equals to 15, and therefore the corresponding side M must be also equal to 15 units in its length. So SM equals to 15 units in its length. What is the length of this element? Element PS. From the drawing, it is very easy to see that PS in total equals 2 PM minus SM. So it is done. If you found out that the missing side PS is equal to PM minus PS. So total PS equals to PM. PM is 25 minus SM. Minus SM. So again, PS equals to PM minus SM. And again, PS equals to PM minus SM. So PS equals to PM, that is 25, minus SM, that is 15. So total PS equals to 25 minus 15, that is 10. This is the missing side PS is equals to 10 units in SM. Again, it is PS, that is 25, minus SM, that is 15. 25 minus 15 is 10. So PS equals to 10 units in SM. In this quadrilateral ABSP, we have 1, 2, 3 triangles, and therefore this fourth missing angle must be equal to 90 degrees in size, and therefore quadrilateral ABPS is 4 triangles, and therefore it is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle, ABSP side PS must be equal to the opposite side AB, but we just right now found out that PS is 10, and the opposite side AB must be also equal to 10 units in its length. So we found out that AB equals to 10 units in its length in two different methods. In the first method, we use the trapezoid mid-segment theorem in order to find out that AB is equal to 10. While in the second method, we did the construction, and then of the story, we found out that AB also equals, we did the construction, we proved that those two rectangles can go into each other according to Eggenstein rule, and therefore we found out actually that AB must be equal to 10 units in its length. So, we can summarize and say that the perimeter of this quadrilateral ABCD, that is to say, the sum of its 4 side lengths is equal to 140 units in its length. So we finish with the first question. In the next step, I present to you the second question, and answer the second question of this lecture. In the second question, this is the second question, our task is to find out the area of this green shape. So in the drawing, we have two semicircles. This is the big semicircle, this is the small semicircle. Again, our task is to find out the area of this green shape. It's given us the question that this is line segment AC, this equals to 4 units in its length. This is line segment CB, this equals to 6 units in its length. Again, our test is to find out the area of this green shape. So first of all, we'll find out the radius of this big semicircle. We define the radius of this big semicircle as R. So the radius R of the big, it's actually capital R, must be equal to the diameter AB over 2. And again, the radius of this big semicircle must be equal to the diameter AB of this big semicircle over 2. AB in total equals to AC, that is 4, plus BC, that is 6. AB in total equals to 4 plus 6, that is 10. Over 2. 10 over 2 is 5. Total, we found out that the radius of the big semicircle R equals to 5. Actually, it is very easy to see to solve this question. Why? Because what is the area of the green shape? The area of the green shape must be equal to the area of the big semicircle. That is actually 25 pi over 2, pi r square over 2. That is 25 pi over 2 minus the area of this small semicircle. So the only missing variable is the radius of this semicircle. So if we define the radius of this semicircle as x, then the area of the green shape must be equal to 25 pi. That is the area of this. Actually, it is 25. It is pi r square over 2. That is to say, r is 5, so pi r square over 2 is 25 pi over 2. That is the area of this big semicircle minus the area of this small semicircle. That will be equal to pi x square over 2. If x is the radius of this small semicircle, then the area of this semicircle, the area of this small semicircle must be equal to pi x square over 2. So in total, the area of the green shape must be equal to 25 pi over 2 minus pi x over 2. So the only missing variable that we have to find is the radius of this small semicircle. Therefore, this is actually a very easy question to solve. Because we have only one variable that we have to find out, that is the radius of this small semicircle. We already found out that the radius of this big semicircle is 5. So we define the radius of this small semicircle as x. And we define the center of this big semicircle as O. We define the center of this small semicircle as point S, and we have we define the radius of this small semicircle as x. So the radius SQ equals to x. And the radius SP of this small semicircle also equals to x. In the next step, we'll join point S and C together by straight line. This is point C. That is the point of tendency of tangent AB with this small semicircle. So we join points S and C together by straight line. What is the definition of line segment SC? Line segment SC starts from point S, that is the center of this small semicircle, and ends at point C, that is the point of the small semicircle itself. Therefore, SC is the radius of this small semicircle, this is equals to x. Repeat again that point C is the point of tendency of tangent AB with this small semicircle. The radius SC, this is equals to x. The radius of SC of this small semicircle, that is equal to x. The radius SC is drawn to point C, that is the point of tendency of tangent AB with this small semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius CS. If AB is perpendicular to CS, it means that this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size, according to rule 1. In the next step, we will do another construction, that is to say, from point P, that is the touching point between this small semicircle and this big semicircle. So from point P, we will go perpendicular on AB. Again, from point P, we will go perpendicular on AB. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point P and AB. This point is point M. What is the definition of line segment MP? Line segment MP is a tangent to this small semicircle at point P. Again, line segment MP is a tangent to this small semicircle at point P. Now now we can implement here all 1. Why? Because we have the radius SP is equals to x. The radius SP of this full semicircle that is equals to x is drawn to point P. That is the point of tendency of tangent MP with this full semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent MP will be perpendicular to the radius PS. If MP is perpendicular to PS, it means that this angle equals to 90 degrees according to rule 1. So in total, in this small quadrangle PSCM, we have 1, 2, 3 angles. Therefore, this fourth angle must be equal to 90 degrees in its size. So quadrangle PSMC has 4 angles. Therefore, it is a rectangle. So as you know, the small quadrangle PSMC is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in this small rectangle PSCM, side PS must be equal to the opposite side MC. But PS is x, therefore the opposite side MC must be also equal to x units in its length. Likewise, according to the sum rule, in the same rectangle PSCM, we have side SC is equal to the opposite side PM. But SC equals to x, therefore the opposite side PM must be also equal to x units in its length. So actually found out that quadrangle PSCM is not a rectangle but a square. Why? Because all of its sides are equal to each other. Each side equals to x. So quadrangle PSCM is a square. In the next step, we will do a construction, that is to say, we complete this big semicircle to a circle. So completed the semicircle to a circle. In the next step, we will extend the tangent PM by straight line until it touches the circle. And we will define the touching point of the extended tangent PM with this circle. This point is point N. So PM is a tangent. PM is a tangent, it is absolutely a straight line. And when you extend a straight line by straight line, the result PN must be also a straight line. So PN is a straight line. So if we focus on the right side of the straight line PN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Repeat again on rule 3, according to rule 3, the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line PN at point M? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So what we have in the drawing? In the drawing we have, this is point O. Point O is the center of the big circle. From point O we have perpendicular OM on chord PN. Again, from point O, that is the center of this big circle, we have perpendicular OM on chord PN. Why OM is perpendicular to PN? Because those two angles are both right angles. So OM is perpendicular on chord PN. And according to rule 15, a perpendicular from the center of the circle towards any chord bisects the chord. Repeat again, according to rule 15, a perpendicular from the center of a circle towards any chord bisect the chord. In the drawing, we have a circle. Point S is the center of this circle. From point S, we have perpendicular ST on chord MN. Again, from point S, that is the center of this circle, we have perpendicular ST on chord MN. And according to this rule, rule 15, perpendicular ST bisect chord MN. If ST bisects chord MN, it means that at point T, chord MN has been bisected into two halves. The first half is MT. It is, of course, equals to the second half Tm, and each half equals to Mn over 2. Again, the first half Tm equals to the second half Tn. Again, the first half Mt equals to the second half Tn. And each half must be equal to Mn over 2 because Mn has been bisected at point T. So we can implement rule 15 in our drawing. Why put in our drawing? From point O, that is the center of this big circle, we have perpendicular OM on chord PN. And according to rule 15, perpendicular OM bisects chord PN. That is to say, chord PN has been bisected at point M. The first half is PM, and it is of course equal to the second half Mn. So in total, according to rule 15, we actually found out that the first half of Pn is Pm, and it must be equal to the second half of Pm, that is Mn. And again, according to rule 15, perpendicular OM bisect chord Pn. That is to say, the first half Pm equals to the second half Mn. The first half Pm as we go to the second half Mn of chord Pn. But we already found out that Pm equals to x. So we can write here that Pm equals to x. And from this equation, x equals to Pm equals to Mn, we will derive that Mn also equals to x units in its length. Mn equals to x. This is the second half Mn. Is equals to x units in its length. What is the length of the short line segment AM? From the drawing, it is very easy to see that the short line segment AM in total it must be equal to AC minus MC. So write it down. AM equals to AC minus MC. So AM in total equals to AC. AC is 4 according to what is given as the equation. AC is 4 according to what is given as the equation minus MC. MC is X. So in total AM equals to 4 minus X units in its length. AM equals to 4 minus X units in its length. What is the length of this short line segment CO? CO equals to CB minus OB. Again, CO equals to CB minus OB. So the short line segment CO equals to CB minus OB. So CO equals to CB, CB is 6 according to what is given as the equation, minus OB. OB is 5, it is the radius of the big circle, that equals to 5. So in total, CO equals to 6 minus 5, that is 1. So CO equals to 1 unit in its length. CO equals to 1. And OB, of course, equals to 5. It is the radius of the big circle, that equals to 5. So here, we can implement rule 24 in our drawing. In our drawing, we have chord AB intersects with chord PN at point M. Again, chord AB, that's actually the diameter of the big circle. Chord AB intersects with this chord PN at point M. So all the requirements of rule 24 are satisfied, and therefore we can implement rule 24. Again, all the requirements of rule 24 are satisfied, and therefore we can implement Now we're going all 24. So repeat quickly on all 24. Only to all 24. First of all 24 is true in any circle. In any circle, if chord AB intersects with chord CD at point O, then the following equation is true. Again, we have chord AB that intersects with chord CB at point O. Point O is the intersection point of chord AB with chord CD. So if chord AB intersects with chord CD at point O, then the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can definitely implement all 24 in our drawing. In our drawing, as I already mentioned before, here, this is chord AB that intersects with chord PN at point M. Again, chord AB intersects with chord PN at point M. So all the requirements for all 24 are satisfied, and therefore we can implement here all 24. Only to all 24, the following equation is true. That AM times MB equals to PM times MN. And again, according to all 24, the following equation is true. That AM times MB equals to PM times MN. We already found out that AM equals to 4 minus X. Times MB. MB equals to 6 units in itself according to what is given as the question. So we'll substitute MB by this is MB. In total, MB equals to MC, that is X, plus CB, that is 6. So in total, MB equals to X plus 6 units in itself. It is MC, that is X, plus CB, that is 6. So in total, MB equals to X plus 6. And it equals to PM. PM is X times Mn. Mn is also X, so X times X is X squared. So in total, according to all 24, we found out that 4 minus X times X plus 6 equals to X squared. So we'll open the brackets on this side of this equation, and finally we get that 4 times X is 4X, and we have here 4 times 6 is 24, equals to minus X times X is minus X squared, and we have minus X times 6 is minus 6X, equals to X squared. So in this side of the equation we have 4X minus 6X is minus 2X, and we have also minus X squared plus 24 equals to X squared. Okay, again, we found out that minus 2X minus X squared plus 24 equals to X squared. Here we will add X squared to the equation, and so you get that minus 2X plus 24 equals to X squared plus X squared is 2X squared. So 2X squared equals to minus 2X plus 24. Here we add 2X to the equation, and finally we get that 24 equals to 2X squared plus 2X. Here we subtract 24 for this equation, and finally we get that 2X squared plus 2X minus 24 equals to 0. And again, in total we should find out that 2X squared plus 2X minus 24 equals to 0. Here we divide this equation by 2. And we get that 2x squared over 2 is x squared, plus 2x over 2 is x, minus 24 over 2 is minus 12, equals to 0 over 2 is 0. So in total we found out that x squared minus 12 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus x minus 12 equals to 0, the variable that we are looking for is x. What is x? According to our definition, x is the radius of this small semicircle. Write it down. We are looking for the variable x, that is the radius of the small semicircle. We only found out that the radius of the big semicircle equals to 5. The coefficient a in our specific quadratic equation equals to 1. The coefficient b equals also to 1. And the coefficient c equals to minus 12. So we have all the data that is needed in order to find out the value of x, or the value of the values of x, that is the radius of the small semicircle. We just have to put the data of our specific quadratic equation inside this general formula for x. This way we find out the value of the values of x, that is the radius of the small semicircle. So we'll do it now, and we get that x equals to minus b. b is 1, so minus b is minus 1, plus minus square root of b squared. b is 1, so b squared is 1 squared, that is 1, minus 4 times a times c. So it is minus 4 times a. a is 1, so minus 4 times 1 is minus 4 times c. c is minus 12, and minus 4 times minus 12 is plus 48. So inside the root we have 1 plus 48 over 2a. a is 1, so 2a is 2 times 1, that is 2. So in total we found out that x equals to minus 1 plus minus 48 plus 1 is 49 over 2. So in total we found out that x equals to minus 1 plus minus the square root of 49 is 7 over 2. And again in total we found out that x equals to minus 1 plus minus 7 over 2. So here we have two solutions that are possible for x. The first solution for x is that x is equals to minus 1 minus 7 over 2. Minus 1 minus 7 is minus 8, and minus 8 over 2 is minus 4. So in total we should found out that x equals to, according to the first solution for x equals to minus 4. But x is the radius of this small semicircle. That is to say, x is a length, and x is a length, it must be a positive number. Therefore, can never be equal to minus 4, that is a negative number, so we cancel the solution, and we take into account only the second solution for x. The second solution for x is as follows: x equals to minus 1 plus 7 over 2. Minus 1 plus 7 is 6, and 6 over 2 is 3. So we found out that the second solution for x is that x equals to 3 units in its length. That is to say, the radius of this small semicircle x equals to 4 units in its length. Again, our task is to find out the area of this green shape. We know that the area of the green shape in total is equal to the area of the big semicircle so it is equal to the area of this big semicircle so we found out that the radius of the big semicircle equals to 5 minus the area of this small semicircle. We only found out that the radius of the small semicircle equals to 3. Therefore, the area of the big semicircle with radius 5 must be equal to pi r square over 2. That is to say, it is pi times 5 square over 2 minus the area of this small semicircle with radius 3. Therefore, the area of the small semicircle must be equal to pi times 3 square over 2. So in total, the area of the green shape equals to pi times 5 square over 2 minus pi times 3 square over 2. 5 square is 25, so in total, in the amount of this expression, we have 25 pi. Three square is 3 square is 9, so in total, this expression, the amount of this expression, we have minus 9 pi over 2. 25 pi minus 9 pi is 16 pi over 2. 16 pi over 2 is 8 pi. In terms of numbers, is equal to 25 25.13 square units in size. And again, if you found out that the area that we are looking for in this question, that is the area of this green shape, in total it is equal to either 8 pi square units in size, or in terms of numbers, it is equal to 25.13 square units in size. So we finish with the second question. In the next step, our summary lecture, we start with the first question, of course. We repeat on the solution of the first question, then we repeat on the solution of this second question. Our task in the first question is to find out the area of this quadrangle ABCD. So it is given the question that this is line segment BQ, this is equal to 10 units in its length. This is line segment QC, this is equal to 40 units in its length. This is line segment QP, this is equal to 20 units in its length. Those three angles are both right angles. Again, our task is to find out the perimeter of this quadrangle ABCD. What is the definition of a perimeter? A perimeter of quadrangle ABCD equals to the sum of its 4 side lengths. That is to say, it is equal to AB plus BC plus CD plus DA. Okay. So in the first step, we did the construction. That is to say, we draw perpendicular on AD at point P. Again, we draw perpendicular on side AD at point P. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We extended the perpendicular from point P until it touches side BC at point M. We find the touching point of the extended perpendicular from point P and this side BC is point M. By doing this construction, you can get here those two one-sided interangles. The sum of those two one-sided interangles is of course 180 degrees, and according to Rule 18, whenever the sum of two one-sided interangles is equal to 180 degrees, then they must be located between parallel lines. That is to say, those two angles must be located between parallel lines. That is to say, AB is parallel to PM, according to Rule 18. Repeating again, Rule 18, according to Rule 18, if the sum of two one-sided interangles is equal to 180 degrees, then they lie between parallel lines. Those two angles alpha and beta are defined as one-sided interangles. So if the sum of those two one-sided interangles is equal to 180 degrees, that is to say if alpha plus beta equals to 180 degrees, then they are located between parallel lines. That is to say, line A is parallel to line B. We already implemented Rule 18 in our drawing. Why? Because you know that the sum of those two one-sided interangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to PM. And again, AB is parallel to PM according to Rule 18. Likewise, the sum of those two one-sided interangles is also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DC. And PM is parallel to DC according to the same rule, Rule 18. Likewise, those two angles, the sum of those two one-sided interangles is also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to DC. AB is parallel to DC. So in total, we have found out that all the three line segments, AB, PM, and DC are parallel to each other. AB is parallel to PM, is parallel to DC according to Rule 18. So here we have AB is parallel to PM is parallel to DC. Whenever you have three or more parallel lines that are connected together by other line segments that are not parallel to each other, here AD connects the three parallel lines by this straight line, and likewise PC connects the three parallel lines AB, PM, and DC by this straight line. And according to basic proportionality theorem, a special relationship exists between the two line segments AD and BC that connects the three parallel lines AB, PM, and DC to each other. The relationship is as follows: AP over PD equals to BM over MC. Again, AP over PD equals to BM over MC. Okay, again, according to the basic proportionality theorem, a special relationship exists between the two line segments AD and BC that connect the three parallel lines together by a straight line. The relationship is as follows: AP over PD equals to BM over MC. It is given as a equation that AB equals to PD. So if we define AP as X, then PD must be also equal to X because they are equal to each other. So we substitute AP by X and PD also by X, and it is also it is equal to BM over MC according to basic proportionality theorem. X over X is 1, so 1 equals to BM over MC. Here we multiply this equation by MC and find out that MC equals to BM. This is to say, BM equals to MC. So at point M, PC has been bisected into two halves. The first half is BM and the second half is MC. And each half, of course, equals to BC over 2 because BC has been bisected. And again, the first half BM equals to the second half MC. Each half must be equal to BC over 2 because BC has been bisected. But BC in total, what is the length of BC in total? Side BC in total equals to BM plus MC. That is to say it is equals to BM, it is equals to BQ plus QC. BQ plus QC. BQ is 10, QC is 40 according to what is given as the question. So total BQ plus QC equals to 10 plus 40, that is 50. So BC in total is 50. Again. BC in total equals to 10 plus 40, that is 50. And BC over 2 is 50 over 2, that is 25. From this long equation, we will derive that BM equals to MC equals to 25. That is to say, this is side BM that equals to 25 units in its length, and this is side MC that is also equals to 25 units in its length. What is the length of this missing element? QM. QM in total equals to BM must be Q. Again, QM equals to BM must be Q. So QM in total equals to BM, that is 25, must be Q, that is 10. So in total, QM equals to 25 minus 10, that is 15. Again, this missing element QM equals to 15 units in its length. In the next step, we implemented the Pythagoras theorem on this right hand triangle PQC. So PQ equals to 20 according to what is given in the question. QM, we just right now found out that QM equals to 15 units in its length, and PM, the opposed PM, is the only missing side. So according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is so this right triangle PQM, PM squared, that is the square of the hypotenuse, equals to PQ squared plus QM squared. So again, according to the Pythagoras theorem, and the right triangle PQM, PM squared, that is the square of the hypotenuse, equals to QM squared plus PM, QM squared plus PQ squared. So PM is the missing side, so it is PM squared equals to QM squared. QM is 15, therefore QM squared is 15 squared, that is 225. Plus PQ squared. PQ is 20, therefore PQ squared is 20 squared, that is 400. So total we found out that PM squared equals to 225 plus 400, that is 625. So PM squared equals to 625. Here we took out of this equation, if I found out that the missing hypotenuse PM equals to the square root of 625, that is 25. This is the missing side PM that equals to 25 units in its length. In the next step, we did another construction, that is to say, from point M, we do perpendicular on BC, on DC. Again, from point M, we do perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point M and DC. This point is point N. By doing this construction, we can do quadrilateral PM and D. Inside quadrilateral PM and D, we have 1, 2 furrow. The sum of furrow is 270 degrees, so 270 degrees plus the size of this surface in total must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this surface must be equal to 90 degrees in its size. So inside quadrilateral PM and D we have 4 angles, and therefore quadrilateral PM and D is a rectangle. In the next step, we defined angle QPM, this angle is alpha. So the right angle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in the triangle. BC is one side of quadrilateral ABCD, so BC is one side of a quadrilateral, it is absolutely a straight line. So if you focus on the left side of the straight line, BC is point M, here the sum of the angles must be equal to 180 degrees according to rule 3. all three sets, then the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of the straight line BC at point M? We have this angle is equal to 90 degrees minus alpha plus 90 degrees plus this third missing angle, in total must be equal to 180 degrees according to all three. So 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. So 180 degrees minus alpha plus this missing angle, in total must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to alpha. Why? Because 90 degrees minus alpha plus alpha is equal to 180 degrees. It is the sum of the angles of the left side of the straight line BC is point M according to all three. Therefore, this missing angle must be equal to alpha. So in this right triangle M and C, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. According to the rule that said that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that this is the green triangle, the green right triangle PQC is congruent to this lower right triangle M and C, according to angle side angle rule. So why those two right triangles congruent to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, the hypotenuse of those two right triangles, that is to say PM equals to MC equals to 25. They are both equal to 25, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So I can prove that those two angles and the side that is included between those two angles in this right triangle, again, those two angles and the side that is included between those two angles, that is side PM on this green right triangle PQM, are correspondingly equal to those two angles and the side that is included between those two angles in this right triangle M and C, that is side MC. Again, those two angles and the side that is included between those two angles, that is side MC on this right triangle M and C, are correspondingly equal to those two angles and the side that is included between those two angles in this triangle PQM. And therefore, those two right triangles can go into each other according to angle side angle rule. And again, if you found out that the green right triangle PQM congruent, this is the sign of congruent to the right triangle M and C according to angle side angle rule. And from the fact that those two right triangles can go into each other, we derive that their corresponding sides must be also equal to each other in their lengths. That is to say, side PQ, the green triangle, must be equal to side MN, this right triangle MNC. So the two corresponding sides. But PQ is 20, therefore MN must be also equal to 20, according to the rule that corresponding sides in congruent triangles are equal to each other. Likewise, QM is the corresponding QM in the green triangle is the corresponding side of NC in this right triangle MNC. But QM equals to 15, therefore NC must be also equal to 15 units in its length. So in total, DC equals to 25 plus 15, that is 40, and MN equals to 15. So in rectangle PM and D, the opposite sides are equal to each other. So PM equals to DN, but PM is 25, and therefore DN must be also equal to 25 units in its length. Likewise, according to the sum rule, in the sum rectangle PM and D, side MN must be equal to the opposite side PD, but MN is 20, therefore the opposite side PD must be also equal to 20 units in its length. The opposite side is X, that is 20, so here X must be also equal to 20, because X equals to 20. So the only missing side that is left to find is side AB, because we already found out that AD in total equals to 40, DC in total equals to also to 40. This is side BC, that is in total it is equals to 50, AB is the only missing side. We found out the missing side AB according by implementing the trapezoid mid-segment theorem on our drawing. First of all, quadrangle AB, this ABCD is a trapezoid, because side AB equals to side DC, AB equals to DC. And a trapezoid is defined as a quadrangle with one pair of quadrant sides. Therefore, quadrangle ABCD is a trapezoid. And what is the definition of line segment PM. PM bisect AD. One point P, AD is being bisected into two halves. Each half equals to 20. Likewise, at point M is the midpoint of BC, because at point M, BC is being bisected into two halves. Each half equals to 25. So in total, PM is the midpoint of AD and BC. That is to say, PM bisects the two legs AD and BC. The two parallel sides AD and DC are defined as the bases of trapezoid ABCD. AD and BC are defined as the legs of this trapezoid ABCD, and line segment PM bisect both legs. So therefore it is defined the mid segment of trapezoid ABCD. But what is the length of the mid segment PM? PM equals to AB plus DC over 2. That is to say, PM equals to the sum of its two parallel bases, that is to say AB plus DC over 2. According to the mid segment, trapezoid mid segment theorem. According to the trapezoid mid segment theorem, the length of the mid segment PM that bisects the two legs of trapezoid ABCD equals to the sum of its two parallel bases, that is to say AB plus DC over 2. We already found out that AB is 10 and DC is, actually, no, we have to find out the value of AB. Okay, so PM equals to AB plus DC over 2. AB is the missing side, so we leave this it is. Plus DC, DC is 40 divided by 2. So in total, we found out that AB plus 40 over 2 equals to 25. Here we multiply the equation by 2 and we found out that 25 times 2 is 50, so 50 equals to AB plus 40. Here we subtract this 40 from this equation, and we found out that AB equals to 50 minus 40, it is 10. AB equals to 10 units in its length. This is the missing side AB, it is equals to 10 units in its length. Repeat again that the perimeter of this trapezoid ABCD equals to the sum of its four lines, the sum of its four sides. That is to say, it is AB that is 10 plus AD that is 40, 10 plus 40 is 50, plus DC that is 40, 40 plus 50 is 90, plus CB that is 50, and 90 plus 50 is 140. So today we found out that the perimeter of quadrilateral ABCD is equal to the perimeter of quadrilateral ABCD, that is actually trapezoid ABCD, is equal to 140 units in its length. In the next step, I presented to you a second method to find out that AB equals to 10 units in its length. In the second method, we did the construction, that is to say from point B, we drew perpendicular on PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PM. This point is point S. By doing this construction, we can do quadrilateral ABSP. In quadrilateral ABSP, we have 1, 2 angles, and therefore this 4 pins must be equal to 90 degrees in its size. So in quadrilateral ABSP, we have 4 angles, and therefore quadrilateral ABSP is a rectangle. By doing this construction, we can do the right upper triangle BSM. In the right upper triangle BSM, this angle equals to 90 degrees, this angle equals to 90 degrees minus alpha, and therefore this first missing angle must be equal to alpha according to the rule that says that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that those two right triangles can move into each other according to angle side angle rule. So why those two triangles can move into each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, the hypotenuses of those two triangles are both equal to 25, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So we should find out that those two triangles can move into each other according to angle side angle rule. That is to say, those two angles and the side that is included between those two angles, that is side that is side BM on this entire BSM, corresponding equal to those two angles, and the side that is included between those two angles, that is side MC in this side line MNC. And therefore, those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we derive that corresponding sides SM and NC must be also equal to each other in the length. Again, from the fact that those two right angles can go into each other, we derive that their corresponding sides must be also equal to each other in the length. That is to say, side NC equals to side SM. But NC is 15, therefore SM must be also equal to 15 units in its length. What is the length of this missing line segment PS? PS equals to PM minus SM. Okay, PS equals to PM minus SM. So PS equals to PM, that is 25, minus SM, that is 15. So in total, PS equals to 25 minus 15, that is 10. This is the missing side PS. This is equals to 10 units in its length. So in arterial ABSP, the opposite sides are equal to each other. So side PS must be equal to the opposite side AB. But PS is 10, therefore the opposite side AB must be also equal to 10 units in its length. So in total, if you found out that the parameter of this quadrilateral ABCD, this is the three trapezoid ABCD, is equal to 140 units in its length. Okay, so we finish to repeat on the first question. In the next step, I repeat on the solution of the second question. In the second question, our task was to find out the area of this ring shape. So in the drawing, we have two semicircles. This is the big semicircle with the diameter AB, and this is the small semicircle. Note that this is line segment AC, this is equals to 4 units in its length. This is line segment CB, this is equals to 6 units in its length. Again, our test is to find out the area of this ring shape. So first of all, we defined the center of this small semicircle, this point is point S. We defined the center of this big semicircle, this point is point O. AB is the diameter of this big semicircle. AB in total equals to AC, that is 4, plus CB, that is 6. So AB in total equals to 4 plus 6, that is 10. If the diameter AB of this big semicircle is 10, it means that the radius must be equal to AB over 2, that is 10 over 2 is 5. So in total, we found out that the radius R of the big semicircle equals to AB over 2, the diameter over 2. The diameter AB is 4 plus 6, that is 10, and 10 over 2 is 5. So the radius of this big semicircle is equal to 5 units in its length. CO equals to CB minus OB. So CO equals to CB, that is 6, minus OB is the radius of the big semicircle, that is 5. So in total, CO equals to 6 minus 5, that is 1. So CO equals to 1 unit in its length. In the next step, we join points S and C together by straight line. Point C is the point of tendency of tangent AB with this small semicircle. Point S is the center of the circle. Point S is the center of the small semicircle. point C is the point of the small semicircle itself, therefore SC is the radius of this small semicircle, that is x. According to our definition, the radius of this small semicircle equals to x. So the radius SP equals to x, and the radius SQ must also equals to x. The radius SC is equals to x, the radius SC is drawn to point C, that is the point of tendency of the AB with this small semicircle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius CS. If AB is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we did another construction. That is to say, from point P, we do perpendicular on AB again. From point P, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. We define the touching point of the perpendicular from point P and AB. This point is point M. By doing this construction, we're going to do quadrilateral PSCM, but here we have, what is the definition of line segment MP? MP is the tangent to this small semicircle at point P. Again, MP is the tangent to this small semicircle at point P. So the radius SP is equals to x. The radius SP is drawn to point P, that is the point of tendency of tangent MP with this semicircle, with this small semicircle. And whenever your radius is drawn to the point of tendency, then tangent MP will be perpendicular to the radius PS. If MP is perpendicular to PS, it means that this angle equals to 90 degrees according to rule 1. So in total, in the small quadrilateral PSCM, we have 1, 2, 3 right angles. And therefore this fourth missing angle must be equal to 90 degrees inside. So in quadrilateral PSCM, we have 5 angles, and therefore it is a left angle. But we also know that the opposite sides of right angle are equal to each other. So in left angle PSCM, side SC must be equal to the opposite side PM, but SC is x, therefore the opposite side PM must be also equal to x units in its length. Likewise, according to the sum rule, in the sum left angle PSCM, side PS must be equal to the opposite side MC, but PS is x, therefore the opposite side MC must be also equal to x units in its length. So in total, we found out that quadrilateral PSCM is not a rectangle but a square. Why? Because all of its sides are equal to each other, they are equal to x. So in the next step, we did another construction. That is to say, we completed this big semicircle to a circle. And again, we completed this big semicircle to a circle. Then we extended tangent PM by side line until it touches this big circle at point N. We find the touching point of the extended tangent PM with this big circle. This point is point N. PM is a tangent, it is absolutely a straight line. When you extend a straight line by straight line, the result PM must be also a straight line. So PM is a straight line. If you focus on the right side of the straight line PN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles on one side of the straight line is equal to 180 degrees. Again, rule 3 said that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line PN at point M? We have this angle that is equal to 90 degrees according to our construction, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to 3. Therefore, this missing angle must be equal to 90 degrees in its size, according to all 3. So in the drawing, we have point O is the center of this big circle. From point O, we have perpendicular OM on chord PN. Again, from point O, we have perpendicular OM on chord PN. Why OM is a perpendicular? Because those two angles are both right angles. So from point O, we have perpendicular OM on chord PN. And according to rule 15, a perpendicular from the center of the circle towards any chord will bisect the chord. On rule 15 again, according to rule 15, a perpendicular from the center of the circle towards any chord bisect the chord. So the drawing, we have a circle. This is point S. That is the point of the center of the circle. So from point S we have the perpendicular ST on chord MN. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. And according to this rule 15, perpendicular ST bisect chord MN. If ST bisects chord MN, it means that at point P, at point T, MN has been bisected into two halves. The first half is MT, and it is of course equal to the second half Tn. Each half must be equal to Mn over 2 because Mn has been bisected. So we can implement rule 15 in our drawing. Why? Because in our drawing we have perpendicular OM on chord Pn. This is to say those two angles are both equal to 90 degrees in their sizes, and according to rule 15, perpendicular OM bisects chord Pn. That is to say at point M, chord Pn has been bisected into two halves. The first half Pm must be equal to the second half Mn. And again, the first half according to rule 15, the first half Pm must be equal to the second half Mn. According to rule 15, the first half of Pn, that is Pm, must be equal to the second half of Pn, that is Mn. But we already found out that Pm equals to x, so we can write here that Pm equals to x, and from this equation x equals to Pm equals to Mn, we derive that Mn must be also equal to x units in its length. This is Mn that is equal to x units in its length according to rule 15. So in the drawing we have chord AB that intersects with chord Pn at point M. Again, chord AB intersects with chord Pn at point M. So all the requirements of rule 24 are satisfied, and therefore we can implement here rule 24. So on page 20 on rule 24, according to rule 24 is true in any circle. So in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. Again, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. So we can implement rule 24 in our drawing. Because in our drawing we have chord AB that intersects with chord PN at point M. So all the requirements of rule 24 are satisfied, therefore we can implement here rule 24. Only to rule 24, AM times MB equals to PM times MN. And again, according to rule 24, AM times MB equals to PM times MN. What is the ref of AM? From the law it is very easy to see that AM in total equals to AC minus MC. So AM equals to AC, that is 4, minus MC, that is X. So in total AM equals to 4 minus X units in its length. So AM equals to 4 minus X times MB. MB in total equals to X plus 6. And again, AM equals to 4 minus X, MB equals to X plus 6. And it equals to PM times Mn. PM is X, Mn is also X. So PM times Mn, in total it is X times X, that is X squared. So in total we found out that 4 minus X equals to X plus 4 minus X times X plus 6 equals to X squared according to rule 24. Here we open the brackets of this expression, and we found out that 4x plus 4 times 6 is 24, minus X times X is minus X squared. Plus 6x equals to x squared. 4x minus 6x is minus 2x, plus 24 minus x squared equals to x squared. So here we did x squared in the equation, and found out that x squared plus x squared is 2x squared. So in total minus 2x plus 24 equals to 2x squared. Here we did 2x to this equation, and found out that 24 equals to 2x plus 2x squared. Here we substitute 24 on this equation, and found out that 2x squared plus 2x minus 24 equals to 0. Here we divided the equation by 2, and found out that 2x squared over 2 is x squared, plus 2x over 2 is x, minus 24 over 12 is minus 24 over 2 is minus 12, equals to 0 over 2 is 0. So in total we should find out that x squared plus x minus 12 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus x minus 12 equals to 0, the variable that we are looking for is x, and x is the radius of this small semicircle. The coefficient a equals to 1, the coefficient b also equals to 1, and the coefficient c equals to minus 12. So the only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the radius of x, that is the radius of the small semicircle. So we did it, and we should find out that x equals to minus b. B is 1, so minus b is minus 1, plus minus square root of b squared. b is 1, so b squared is 1 squared, that is 1, minus 4 times a times c. So this is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is minus 12, so minus 4 times minus 12 is plus 48. So in total inside the brackets we have 1 plus 48 over 2a. A is 1, so a is 2 times 1, that is 2. So in total if you found out that x equals to minus 1 plus minus inside the root we have 48 plus 1, that is 49 over 2. The square root of 49 is 7. So in total if you found out that x equals to minus 1 plus minus 7 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 1 minus 7 over 2. Minus 1 minus 7 is minus 8, and minus 8 over 2 is minus 4. So according to the first solution for x, x equals to minus 4. But x is the radius of this small semicircle, so x is the length, and s as the length, it must be a positive number. It can never be equal to minus 4, that is a negative number. So we consider the first solution for x, and take into account only the second solution for x. The second solution for x is x equals to minus 1 plus 7 over 2. Minus 1 plus 7 is 6, and 6 over 2 is 3. So the second solution for x is the radius of this small semicircle x equals to 2 units in its length. Again, our task is to find out the area of this green shape. The area of the green shape is equals to the area of the big semicircle minus the area of the small semicircle. The radius of the small semicircle is 5, and therefore the area of the small semicircle must be equal to pi times pi squared over 2. Minus the area of the small semicircle. The radius of the small semicircle is 5, and therefore the area of the small semicircle must be equal to pi times pi squared over 2. Here we have 5 squared is 25, so in total in the numerator we have 25 pi divided by 2. Here 3 squared is 9, so in total in the numerator of this expression we have 9 pi divided by 2. 25 pi minus 9 pi is 16 pi, which is 16 pi over 2, that is 8 pi. 8 pi in terms of numbers is equals to 25 minus 1 3 square units in size. So in total if you found out that the area that we are looking for in this question, that is the area of this green shape, it is equal to either 8 pi square units in size. In terms of numbers, it is equal to 1.3, it is equal to 25.13 square units in size. Okay, thank you very much.